This video is about application of integral area. We know the value a is known as the definite integral of f of x from a to b, written a equals this. If f of x greater than equal to 0 for all x greater than equals to a less than equal to b, then this definite integral is equal to the shaded area, like this. Now let's discuss these questions. Does definite integral of f of x from a to b always give us an area? For number 1, find these three definite integral. We know x to the third power. That's indefinite integral equals x to the fourth power over 4. So for number 1, I can write down that is x to the fourth power over 4 from 0 to 1. You will get the 1 over 4. For second one, you will get x to the fourth power over 4 from -1 to 0. So you will get the 0 minus 1 over 4 give to you -1 over 4. For this one, you will get x fourth power over 4 from -1 to 1. So you get the 1 to the fourth power over 4 minus -1 to the fourth power over 4. You will get 0. When we figure out this definite integral, we get 1 over 4, we got -1 over 4 and a 0. As we know, area never be negative or 0. Therefore, this definite integral doesn't always give us an area. If we put these three definite integrals into a graphing calculator, you could say if we're looking for the definite integral above the x-axis, you will get positive. If it's below this x-axis, you will get negative. And 1 is positive, 1 is negative. This is a positive 1 over 4. Here's -1 over 4. Therefore, you will get 0 as the solution. For number 2, find the area bounded by x-axis and f of x equals x to the third power, the x between -1 to 1. From the graph, we could say the area will be 1 over 4 plus 1 over 4. Let's label here's A1, this is A2. So the area equals A1 minus A2. That is 1 over 4 plus 1 over 4 equals 1 over 2. Suppose f of x is a function such as f of x less than equal to 0 for all x between a and b. Can you suggest an expression for the area between the curve and x-axis for x between a and b? If it's less than or equal to 0, which means the graph look like this. This is A, here's B. Therefore, the area equals, you will get the negative, the definite integral of f of x from a to b. So you have to put the negative sign. Or you can write down that is from b to a, definite integral of f of x, because this will give to you positive. So when you're looking for the area bounded by x-axis and a function, you have to be very careful. If the function above x-axis, then you will get a self, that's a1. But for the part below x-axis, you have to get a opposite, get a negative a2. If you put this into a graphing calculator, you can get the area equals definite integral of absolute value of f of x from a to b. This formula is very useful when you use a graphing calculator. Without graphing calculator, you have to figure out this x-intercept, and also you need to figure out for which interval the graph is above x-axis, from what interval the graph is below x-axis. Then use this formula to figure out the area. If we are looking for the area bounded by two functions, you have to figure out this intersection first. Then make sure the subtraction of the graph is a positive. For example, we do know that from a to b, that's f of x. This is f of x. Is above g of x. Therefore, we use f of x minus g of x from a to b. From b to c, we do know that g of x is above f of x. So we do the definite integral of g of x minus f of x from b to c. Then we add this number together. You will get the area bounded by two functions. Now let's go to guided practice 2. Evaluate the following integrals using area interpretation. For A, we're looking for from 0 to 4. That integral of f of x. That means this area. We use pi r squared over 2 to figure this out. Then the radians, that is 2. So you get the pi 2 squared over 2. You will get 2 pi. Since this is above x-axis, therefore, you will get the 2 pi. It's a positive. Now let's go to B. Definite integral of f of x from 4 to 6. That means this area. Since this is below x-axis, your value will be negative. The area for this square is 2 times 2 equals 4. Therefore, for this definite integral will be negative 4. Let's go to C. definite integral of f of x from 6 to 8. That means this one. You got to use pi r squared over 2. We do know that r equals 1, so pi times 1 squared over 2. That equals pi over 2. For d, that's a definite integral of f of x from 0 to 8. You will get the 2 pi minus 4 plus pi over 2. Combine like terms, you will get the 5 pi over 2 minus 4. Now let's go to E. We are looking for the definite integral of absolute value of f of x from 0 to 8. This absolute value means we are looking for the area bounded by the function and x-axis. Therefore, you have 2 pi plus, not negative 4, it's positive 4 plus pi over 2. So your answer will be 5 pi over 2 plus 4. Now let's go to guided practice 3. Write an expression for the total shaded area. First of all, we label function for each interval. So we have, this is f of x here, and f of x. This will be g of x, here's g of x. Therefore, this area equals, for the interval a to b, you will get f of x minus g of x. Then plus, from b to c, you got to do g of x minus f of x. Then from c to d, you have to do f of x minus g of x. You add all these three together, you will get the area bounded by these two functions. So when you figure out the area bounded by two functions, you have to make sure the difference is positive. That's why I use f of x minus g of x when we do the interval from a to b. From b to c, we do g of x minus f of x. For the interval c to d, we do f of x over g of x. Now let's go to guided practice 4. No calculator based. Find the total area of the regions contained by y equals x, third power plus x squared minus 2x and the x-axis. First of all, we have to factor this polynomial. Common factor is x, so we get the x squared plus x minus 2. Then we keep factoring. You will get the x times x plus 2, then x minus 1. Since we cannot use a graphing calculator, you have to draw the sign diagram so that we can predict the graph. Your x1 equals 0, x2 equals negative 2, x3 equals to 1. So we get, here is a negative 2, 0, this is 1. Then we find a special number 2. Plug into the function f of 2. We check it's positive or negative. We plug in 2 into this function, you will get the 2 times 2 plus 2, then 2 minus 1. Positive, positive, positive. That means f of 2 greater than 0. So we put the positive sign for this interval. Since for this polynomial function, it's a single factor, so we have to change the sign for each neighborhood interval. That is negative, positive, negative. So we can predict the graph like this. Positive, that means above x-axis. Negative means below, then go this way. Since we are looking for the total area of region contained by this function and x-axis, so we're looking for this area and this area. Let's label this is a A1, here's a A2. For the A1 part, you will get definite integral of x third power plus x squared minus 2x from negative 2 to 0. For A2, you will get definite integral of x third power plus x squared minus 2x from 0 to 1. So we get the x to the fourth power over 4 plus x third power over 3 minus 2 times x squared over 2. Then from negative 2 to 0. We organize this just like x squared. So we plug in 0 first. You will get the 0. Minus, don't forget this minus. Then we plug in negative 2. So you get negative 2 to the fourth power over 4 plus negative 2 to the third power over 3. Then minus negative 2 squared. This gives you 4 because 16 over 4 is 4. This gives to you negative 8 over 3. Then minus 4. So basically you will get the negative 8 over 3. That is 8 over 3. Now let's go to this A2. We do the same thing. So you get the x to the fourth power over 4 plus x third power over 3 minus 2 times x squared over 2. Then from 0 to 1. We just need to plug in 1 into this function. Because you plug in 0, it's still 0. So you get the 1 fourth power over 4 plus 1 third power over 3 minus 1 squared. Now you will get the 1 over 4 plus 1 over 3 minus 1. That is a 7 over 12 minus 1 gives you negative 5 over 12. The total area equals A1 minus A2. So you get the 8 over 3 plus 5 over 12. We multiply by 4. You will get 32 over 12 plus 5 over 12. Final answer will be 37 over 12. Let's go to B. Find the total area of regions contained by y equals x to the fourth power minus 5x squared plus 4 and x axis. Since we cannot use graphing calculator, you have to factor this polynomial, that is x squared minus 4, then x squared minus 1. So you get the x plus 2, x minus 2, x plus 1, x minus 1. We will get the roots x1 equals negative 2, x2 equals 2, x3 equals negative 1, x4 equals 1. So we draw the sign diagram. You will have a negative 2, negative 1, 1 and a 2. Let's choose 0 as a special number. So f of 0 we plug in. You will get the positive, negative, positive, negative. Then multiply. You will get the positive number. So here's positive. Since for this polynomial, the factor are all single factor, which means the neighbor interval, the sign is changing. So you get the negative, positive, negative, positive. We can sketch the graph like this. Here's positive, negative, negative, then going up like this. We're looking for the total area, which means these three area we add together. We label here's A1, A2, A3. So total area equals negative A1 plus A2 minus A3. Remember, the definite integral below x-axis is negative. Then we're working on the A1 first. We know the indefinite integral of x4 minus 5x squared plus 4. That equals x to the fifth power over 5 minus 5 times x third power over 3 plus 4x plus c. So we have this. Here's x fifth power over 5 minus 5 x third power over 3 plus 4x from negative 2 to negative 1. Then we plug negative 1 first. You will get negative 1 over 5 plus 5 over 3 minus 4. Then minus parentheses, you plug in negative 2. You will get negative 32 over 5 positive 40 over 3. Then minus 8. So you do distributive property. You will get negative 1 over 5 plus 5 over 3 minus 4. Then plus 32 over 5 minus 40 over 3 plus 8. Then you put this together, you will get the negative 22 over 15. Now for the A2. You will get the x fifth power over 5 minus 5x third power over 3 plus 4x. This time we from negative 1 to 1. So we plug in 1, you will get 1 over 5 minus 5 over 3 plus 4. Then minus parentheses. You plug in negative 1, basically it's this number. So we get negative 1 over 5 plus 5 over 3 minus 4. do the distributive property. You will get 1 over 5 minus 5 over 3 plus 4 plus 1 over 5 minus 5 over 3 plus 4. You put this together, you will get 76 over 15. We do the same thing for A3. You will get x fifth power over 5 minus 5x third power over 3 plus 4x from 1 to 2. Plug 2 first, you will get 32 over 5 minus 40 over 3 plus 8. Then minus parentheses. We plug in 1, you will get this. So we write down 1 over 5 minus 5 over 3 plus 4. Then we do distributive property. Then put this together, you will get negative 22 over 15. So we get the total area equals 22 over 15 plus 76 over 15, then plus 22 over 15 equals 8.